So last time we talked about the kinetic molecular theory of gases, which talks about the molecular motion or movement of the gases and how that relates to the characteristics of gases. And then we also talked about the different natures of gases and the characteristics. Now we're going to get into pressure and volume and temperature conversions. So the first thing we need to know is what is standard temperature and standard pressure, which is abbreviated STP. S for standard, T for temperature, P for pressure. So STP is basically used for an easy comparison between different types of gases. So standard temperature, if you're in Celsius scale, it's 0, and there's a degree sign. If you're in the Kelvin temperature scale, which we'll talk about in a minute, it's 273. So either of those can be used depending on the situation. And then standard pressure is 1 atm. So if I ask you what are the values of STP, you could say 0 Celsius 1 atm, or you could say 273 Kelvin 1 atm. And then standard volume, which isn't included in the acronym, but we need to know it, is 22.4 liters. So make sure you know those values. You're going to need them. So why do we have the Fahrenheit temperature scale, Celsius, and the Kelvin temperature scale? Well, Lord Kelvin developed his temperature scale named after him because he wanted to avoid negative numbers in calculations. So think about, you can have negative Celsius, you can have negative Fahrenheit. Way back in the day, carrying those negative values made it challenging for calculations without a calculator. So he decided to create his own temperature scale that basically avoided negative numbers. So the Kelvin temperature scale takes Celsius and converts it to Kelvin. So all you do is you take your degrees Celsius and you add 273. That's it. So adding that number gives you a value that is 99% of the time above 0. And the Kelvin temperature scale does not have the degree sign. So it's just capital K instead of degree sign Celsius or degree sign Fahrenheit. And we're not going to talk about the Fahrenheit temperature scale at all because scientists don't use it. So some important temperatures you need to know, or an important temperature you need to know, is absolute 0. So absolute 0 is actually a theoretical value. It's the temperature at which all matter ceases motion. So all molecules stop moving. It's such a cold temperature, though, it can't actually be obtained in our world. So it's a theoretical value, but it has a purpose. So degrees Celsius, absolute 0 temperature is negative 273.15, but negative 273. The Fahrenheit is even lower, or you could just say 0 Kelvin, because you take your Celsius and you add 273. So negative 273 plus 273 gives you about 0 Kelvin. So I would just remember 0 Kelvin. That's fine with me. And then just remember that water freezes at 32 degrees Fahrenheit or 0 degrees Celsius or 273 Kelvin. So it just depends on what type of temperature scale you want to look at as to which value you will use. Okay, so our first conversion is going to be volume conversion. So you don't need to write this chart down. These are common units of volume. Liter is capital L or lowercase cursive l. Milliliter is lowercase m capital L or lowercase m cursive lowercase l. Cubic decimeter is dm to the third cubed. And then cubic centimeter is cm cubed or cc. So just make sure you know those abbreviations, and you may already know them. Okay, this is a chart that you'll be referencing for all of your volume conversions. You don't have to memorize it. It will be given to you on the test, but you'll need to reference this for all of those mathematical calculations. So 1 liter is equal to 1,000 milliliters. I'm sure you probably know that. 1 milliliter is equal to 1 cubic centimeter, whichever abbreviation you want to use. And 1 liter is equal to 1 decimeter. So once again, just make sure you know this. So first example. I'm not going to do all these with you. You can do them on your own. I think you'll get the point very quickly. So it says, Convert 753 milliliters first to liters. So number one, and you need to show your work for this. I know that these are easy calculations and you can probably do them in your head, but for this chapter, please show them. So I've got 753 milliliters. I need to go back and reference my chart. So I'm going to be using this one. 1 liter is equal to 1,000 milliliters. So I start with that. 1 liter, because I'm going to liters on the top, is equal to 1,000 milliliters. That's going to go on the bottom because the milliliter has to cancel milliliter. And then you just do the math. 753 times 1 divided by 1,000. And you get 0.753 liters. That's your final answer. Now people say, Ms. Minkowski, I can do that in my head. Just move the decimal. Do I have to show the work? For right now, yes. When we get more complicated, not necessarily. But for right now, that's all I'm asking you to do. Please show it. All right, the second one is taking 753 milliliters and converting it to cubic centimeters. So go back to your chart. Now you're going to be using this one. 1 milliliter equals 1 cubic centimeter. So I've got my milliliter on the top, or to start with. I'm going to cubic centimeters. 1 cubic centimeter is equal to 1 milliliter. So 753 times 1 divided by 1. My units cancel. I get 753 cubic centimeters, or you could use cm cubed, whichever. That was an easy one. You just have to know where to put the numbers. And the third one, I'm taking 753 milliliters, and I am converting to decimeters. And this should be to the third power. That's my fault. So going back, 1 liter equals 1 decimeter. I need that one, but I also need 1 liter equals 1,000 milliliters. I have 2 conversions now. So I first have to go from milliliters to liters because there's no conversion that takes me directly to decimeters from milliliters. So I do this first. My milliliters cancels my milliliters. Now I'm in liters. Now I can go 1 decimeter is equal to 1 liter. And then that cancels that. So you have to do 2 steps here. So 753 divided by 1,000 times 1, and I get 0.753 decimeters. So like I said, easy calculations. For right now, show the math just for good measure. Okay, here's some more examples if you want to try them. So convert 7.2 liters to milliliters, cubic centimeters, and cubic decimeters. So I'll give you the answer in case you want to try it out. Can't hurt to practice. So try those out on your own. Let me know if you have any questions. So that's volume conversions. Next up, we have pressure conversions. So first up, what is pressure? Pressure is basically how much force is on a unit of surface area. So force per unit area on the surface. It's measured with a barometer. Used to look like this in the picture, very fancy looking. Now it's just an electrical device. A barometer measures atmospheric pressure from the atmosphere. It was first used and measured by Torricelli, and he used millimeters of mercury, mercury being the metal liquid, or liquid metal. And he actually uses this to predict weather, and they still use barometers to predict weather. So changes in pressure signify changes in weather conditions. So once again, some common abbreviations. Atmosphere is ATM, millimeters, MM, of mercury, capital HG for mercury, MMHG, kilopascal, KPA with a capital P, and then Torricelli, Tor. And then there's your standard value for all of them. And then here is your pressure unit conversion chart. So once again, you'll need to reference this for the mathematical portion. So 1 ATM is equal to 760 torr. 1 kPa is equal to 7.5 torr. And 1 torr is equal to 1 millimeter of mercury. So make sure you know that. But once again, you don't have to memorize it. So converting pressures. The average atmospheric pressure in Denver is 0.83 ATM. Express this unit as millimeters of mercury and as kPa. So for the first one, I need to go back to my chart. I'm going from ATM to millimeter of mercury. Well, notice there's nothing that says ATM millimeter of mercury. So I need to use this one first, ATM to torr, and then I can go torr to mercury. So I need two conversions. So make sure units cancel out. 1 ATM is equal to 760 torr. So my ATMs cancel out. Now I'm in torrs. Now I can go from torr to mercury. 1 torr is equal to 1 millimeter of mercury. And once again, those cancel out. Now I'm in millimeters of mercury. So 0.83 times 760, and then divided by 1 times 1, all that stuff. And I get 630.8 mmHg. And make sure that H is capital. Okay, pretty simple. You just gotta know where to put what. Whoops. Second part, 0.83 ATM. Units count for this, make sure you have them, to kPa. So going back to my chart, ATM to kPa. Once again, there's nothing that says ATM directly to kPa. So I have to use ATM to torr and then torr to kPa. So once again, 2 steps. So ATM to torr again, 760 torr is equal to 1 ATM. And then I can go from torr to kPa. So 7.5 torr is equal to 1 kPa. And I'm just taking the number from the chart, guys. 7.5 torr, 1, whoops. Sorry about that. 7.5 torr to 1 kPa. So when I put it in my equation, I have 7.5 torr, because torr has to cancel torr, and 1 kPa on the top. So it's just about placement. So do all that math, and you should get 8.84.11 kPa. Okay, once again, if you want some extra practice, convert 570 torr to ATM to kPa and to mmHg. It can't hurt to have a little bit more practice. So here are the answers. Try them out. Let me know if you have any questions. You need to understand this to do the second half of the chapter, gas laws. So if you have any questions, make sure you chat me, or you can Zoom with me on Wednesday, or we can schedule a time. But this is getting into the mathematical portion of gas laws. So make sure you understand pressure conversions and volume conversions, and then temperature conversions is just degrees Celsius plus 273 gives you Kelvin.